profile that you did your master about genetics of blood tolerance in barley. As barley breeder, I would like to ask if you try to use your technology on these topics. Second question is about VYTV gene resistance gene. So you, in my knowledge, YT4 is detected only on spontaneum. So did you have some work on YT2 gene, which is the most resistant used in breeding? Thanks.
Right, this one. So maybe the first question. Oh yeah. First question. We did use the technology to work on drought resistance in GP, but never in barley yet. But we'd be very happy to do that. As in the company, we are depending, of course, on our customers, so we cannot decide ourselves what we want to do. Of course, I would personally have liked to work on that. But concerning the BYD virus resistance, this was introduced. I wasn't explaining the whole story, but we have worked with introgression lines, and so the resistance gene was introgressed from Oleum bulbosum into the Bulgaria, and so the material was there, but the genetic markers were very bad. So this is why we needed to find more closely connected markers, and we used the Mayseq approach to find those markers. And then these were able to separate between this lethal factor that was also introduced during this introgression and between the gene of interest, which was for the B1EB resistance.
Another question regarding the Mace technique.
Yes.
You say that you sequenced the primary end of grain, and probably you are sequencing also the untranslated region.
Yes.
So my question concerning this technique, probably if some mutation concerns exons, then probably you miss out some interesting mutation providing resistance at the 5 prime.
Yes. Indeed. We cannot see everything, so this is like a compromise between GBS, genotyping by sequencing, because it has the same principle that we're not sequencing, like in GBS you're not sequencing the entire genome, but only parts of the genome, but always the same parts. And this is the same thing. So we are generating markers that are located within the gene itself, but of course if there is maybe a mutation responsible for resistance or other trait, then of course if this mutation is not in the region that we're focusing at, then this we will not see. But even if we don't see it, we have a very high chance that by having the marker within the gene itself, the 3' end is very likely to be also different, even if they're, so we will find it, we might not find the real reason, but we will find the same connection. We will find the gene that is responsible for that, usually, because we have so many polymorphisms. But indeed, yes, in this case, I would suggest, if you know, then you can as well do RNA-seq, but you have to spend a little bit more money on the sequencing. Yeah.
So we have a couple of questions. First to Albert, the orthophosphate crystal. How difficult it is for a farmer or for a technician to do the seed treatment? Is it something very commonly done? And is it available commercially or is it still in pilot phase?
No, it's not in a pilot phase because we already applied such material to seeds. It was done by 2 separate operating companies in Germany who are experts in seed treatment. And I rather would say it's simple because there was no problem at all. It's just a matter of you want to choose a polymer-based or water-soluble-based coating system. Both is working, and it should be easily done also with basic technologies because in the first instance in the first year I did it by myself at home, so it should work easily.
Thank you. My other question is to Bjorn. How often did you find a 3' end where there was no snips at all? Is that something you encountered, or?
Yeah, well, this is fortunately quite rare. But of course, if you have very, very closely related species, then of course the chance increases. Like if you have breeding material that is extremely similar, then the chance might increase. But we haven't seen it in our daily work, because maybe the lines that we were working with were different enough. So it's fortunately very rare.
Very quickly. Related to fertilizers, I think it seems like there is one aspect that needs to be considered when doing fertilizers, is the germplasm itself. Because there are some that will be fixing, that will, you can find higher reflected fertilizer, higher rate of fixing iron or zinc or whatever, and you might have some other genotype that will not, you apply whatever in terms of fertilizer, you will not find it in the product itself. So there is some genetic capacity of genotypes that will be fixing or not fixing the fertilizers. Second aspect is BYDV. BYDV you can work on you can work on YD2 genes, YD3, but if the vector that is transferring this is different from repulsifum padi or repulsifum IDs, you can have surprises that those YD2s will not be affected at all. So I think I have the experience of working on YD2 for some years. You do all the process. Whenever the vector is changing, you have completely susceptibility of your genotype that was supposed to be resistant to YD2. So that's something that I was thinking that the genes that you are identifying is something that is new, and I hope that it's new.
Maybe a few words concerning the first aspect. Yes, we are fully aware that there are differences between plant species and plant varieties itself. And we did assessments on summer barley in Denmark and in Germany with the manganese seed treatment. And honestly speaking, I'm not in such sophisticated business like all of you are in sequencing genes. Fertilizer application is very much different. It is a try and error system and seeing if there is an improvement or not. But it's very simple to be done and also could be done over here.
Yeah, I think I agree. Of course, this is within the system that we were working with which is transmitted by aphids, and I don't know too many details if there are other factors, etc. It worked very well, and this is now used for the breeding programs of all the connected companies that are using this now in their lines.
Following the question to the Albert on fertilizer, and on the seed coating with the phosphate complex. We know that phosphate is not solubilized by plants. It's very difficult to be acquired by plants. And it's the most waste in terms of fertilizer for plants. So you can put a lot of phosphate and plants will take very few. So it's a problem. And many scientists are hardly working to find out solution to mobilize much of the phosphate. Canute technique is a new challenge to find out to mobilize much, as you quoted, very close to the seed, to the root system, that the plant can take it. We know that there are many genes that are phosphate transporters that many scientists are working to increase it and to overexpress those genes to mobilize as much as they can for the phosphate and to minimize the waste of fertilizer because it's costly, especially for farmers.
Well, I'm fully aware phosphate is a difficult element for plant nutrition. different ways to optimize it, to optimize mycorrhiza, for example, or to add mycorrhiza, different bacteria, etc. The other way is to use a different form of phosphate. You know, there are many highly water-soluble phosphate, like diamine phosphate, monoamine phosphate. On the one side, on the other side, you have a very strong fixed material. It can be ground fertilized phosphates from rock phosphate. It can be calcium phosphate, mono D3 calcium phosphate with different solubilizing characteristics. On the other side, it can be a different crystal. How I just introduced one. What I experienced with at least this product, it's functioning like a depot, and if the depot is empty, the product cannot extract anything anymore. There is still an open question: how long does such a depot last? And this is, well, it is fairly simple to analyze, but I would need to have a certain budget to analyze it, honestly speaking, because these kind of biological assessments would last for longer, not only 1 year, but also 1 to 3 years. Because I know that there are crystals of this kind that can last longer than just 1 season. Does it answer your question? Not 100%, I'm sure. But there are always some open questions in developing new products. Yes.
Good morning. My question is for Mr. Albert. It is known that the Algerian schools are known that the rate of chemicals is high. If your product have been done some experiments to try this way.
Yes. The product has been developed within 5-6 years. And when you have field assessments, 3-year field assessments we have available. It's a long list of data. I didn't want to show data of this kind here because it would be exploding my presentation to a longer one. But just one example, we did trials in Italy, in the Bologna region, in the Po River Valley plateau. And you might know the pH of loose soils is very high, above 8, pH 8, and the organic matter is very low. So it's fairly similar to the situation of many soils in Algeria. And we experienced that the product itself is very good available at high pH, and it's very good available at times of drought. If the soil is dry, for chelates and also for iron sulfate products, they need to have water to be solubilized, and the ions need to be taken up after the solubilization. In this case, the plant itself decides when to pick up the product, and it's solubilizing the product and the ions itself, and not via water systems also kind. So it's much more available in draft situations, and I can prove this by means of field trials.
Good morning. I have a question for Dr. Rotter. You said that your main technique is much more power to detect the real transducer, but you may lose some information coming from distant niche. Okay? Yes. But what about alternative splicing? I mean, how much information coming from alternative splicing to expect to lose? Yeah. And the second question, you know that often RNA degradation is targeted from 3' end. So is your technique more demanding in terms of the RNA quality?
No, not at all, because we often work with degraded RNA, and this has also some advantages because if you want to do a regular RNA-seq approach, you need to know how long the RNA molecule really was. And if you have degradation, then of course the original RNA, you don't know what splicing variant you will have, etc. You don't know how long it was. And so the normalization will not really work. And with this approach, since we are only getting one read per transcript, the quantification is highly accurate. Of course, you cannot see all the splicing, etc. But this is beyond what we are looking for. It's supposed to be a very cost-efficient, cheap analysis, like if you're comparing RevSeq with genome sequencing, or So it's the same approach. So it's very cost-efficient and giving you snips from genes. And at the same time, it gives you very high-resolution gene expression profiles. So we measure about 20 to 25,000 different transcripts very accurately using the MACE approach. So it's basically all the genes, of course, expressed at different levels. We also have now worked on a system to deplete very frequent transcripts, for example, in plants, the photosynthesis genes, to get rid of them in order to concentrate more on the other genes, because they will otherwise take a big part of the transcript. So, yes, of course, you cannot see everything, like splicing, like 5' snips, but I like to compare it with GBS. So you cannot see everything, but you get what you need in most cases.
Ok, encore une dernière question, les deux dernières questions. D'abord Anna, ensuite.
Okay, good morning. Thanks for all the presenters and the speakers. I have two questions. First, for Dr. ALSharama. If you prepare chips for SNPs, and according to the request of the scientists, like this specific chips for weight and that film for aluminum. This is the first one. And if it's okay, what is the number of SNPs you offer, and what is the price?
Sorry, yeah. All right. So you're talking about arrays, right?
Yes.
Okay, we are only using NGS, but we are using like more open architecture technologies that allow to analyze any species. For the chip, you must prepare the chips beforehand, and you have to generate the chip, and that is quite costly. Of course, then you can go down with the price because if you have many chips, then the price. But even that. Well, I did this but a couple of years ago. We designed a chip, but unfortunately I don't know because we don't do it very much, and so maybe the prices have changed. I think nowadays you can work as good with GPS technology or maybe with a MACE-seq approach and get in the same range of costs as for the arrays today, because you don't need to do. You have a more open system. It's more open architecture. With the chip, you're focused on the SNPs. If they are maybe not productive or informative, then you have to redesign the entire chip, and this can be quite costly. So I think with the advance of next-gen sequencing, you might be better by using NGS directly instead of using the arrays today. That's my personal opinion.
For the second,
Dernière question, s'il vous plaît, pour le concours. Vous pouvez discuter par la suite.
and you say that you offer the kit with the bioinformatics.
Yes.
This is bioinformatics analysis or software?
It's a bioinformatics analysis. So yeah, so it's via our servers. So you can either do it yourself, or you can, if you don't have much bioinformatician or experience in this field, you can simply send us the data, also the other data that you might have, and we will analyze it for you, and you will get back the results in forms of tables, plots, and graphics, etc.
Go ahead.
in fact, kind of analytic information about the phosphate application in order to restore some of the micronutrients. Just to remind that in the late 80s, research has been conducted in the east of Algeria, in Annaba, in particular, in the flooding region of the west of Annaba, using the natural phosphate called the Jebel from the south of southeast, from Tebessa. So the work is undertaken in joint program with the university and the structures of the industry. I don't know exactly now what is going on, but it has been done. The second question is for Dr. Rotter. I heard you have been talking about the BYDB, and just to inform you, also in the late 80s, a joint program had been done with the University of Montpellier and Canada, Professor Andrew Como. And this work had the potential to see the strength correlation between aphids tolerance and BYDB tolerance in parlays. And this had been done by some fellows from Morocco, I guess, and the positive determined, I believe, quite Idris. So some interesting result have been obtained on whether or not it does exist this kind of relationship between BYDB tolerance and aphids tolerance. Now, the molecular tools has to pursue this way. I don't know if it's your point of thank you.
Thank you, yes. I can well imagine that if because the transfection is really, in this case, for this virus, at least by aphids, so if there is resistance towards aphids, maybe by stronger cell wall, etc., maybe that could also render resistance. But this mechanism is different. We don't know the gene yet, but we have only few candidates, and we will see what it looks like a classical resistance gene.